Today we are going to be looking at Theorem 2 from our circle geometry series. Let us get right into it. In our previous video, we talked about Theorem 1. I stated the theorem and we were able to explain what it meant and tackle problem using Theorem 1. Please do well to check that video out so that you can catch up with us. This is Theorem 2, and Theorem 2 is just stated as written on the board also. The angle subtended by an arc of a circle at the center is twice the angle which it subtends at any point on the circumference. I know that this theorem can look as a lot going on, but I am here to break it down for you. So what is Theorem 2 actually saying? So drawn on the board is a circle, and I want to assume that this is the center of that circle. Okay, so what I need to do is to make sure that there is an angle subtended at the center of the circle. For me to produce an angle subtended at the center of the circle, all I need to do is draw two lines just like this. Of course, we know that those lines are the radius of that circle because it is a line drawn from the center to this point on the circumference. By drawing those two lines, what I am able to achieve is there is an angle subtended at the center of that circle. Okay, what Theorem 2 just simply tells me is that this angle subtended at the center of the circle is always going to be 2 times the angle subtended at any other point on the circumference, provided they subtend the same arc. So, provided they subtend the same arc, this arc. If I draw another angle, just produce 2 lines also. But what am I achieving with these 2 lines? There is another angle subtended. Okay, so if this is angle A and this is angle B, from Theorem 2, the angle at the center is always going to be twice the angle subtended at any other point on the circumference. So A is going to be 2B. That is simply what Theorem 2 is saying. Another implication of Theorem 2 is what we want to look at right now. Remember, from Theorem 2, we know that the angle at the center is always going to be 2 times the angle at any other point on the circumference, provided those angles subtend the same arc. Now, this is the angle at the center, 180 degrees, of course, because this is just the diameter of that circle. So it is a straight line that touches both ends of the circumference of that circle. And just as we know, the angle on every straight line is 180 degrees. So 180 degrees being the angle at the center, it is going to be 2 times the angle on this point of the circumference. And when I divide both sides by 2, x becomes 90 degrees. And this is an implication of Theorem 2. What is that implication? In a semicircle, the angle is always 90 degrees. This is an example of a question that can be thrown at you. And of course, how you go about this question, all you just need to take note of is Theorem 2. So, looking at the question, it says, obtain the angles x and y, given that O is the center of the circle. And I have the diagram, okay, telling me to obtain angle x and angle y. From Theorem 2, we have stated that the angle at the center is always going to be twice the angle subtended at any other point on the circumference. There is a catch there, provided the angles are facing the same arc. Okay, so for me to be able to get angle y, I notice that this angle and this angle are all facing this portion of the arc. Okay, so I can apply Theorem 2 here. 114 degrees is always going to be 2y. Angle at the center is twice the angle at this point on the circumference. Why am I using this? Because they are facing the same arc. Of course, dividing both sides by 2, y becomes 57 degrees. To obtain x is also quite simple. All I need to do is obtain this angle. Okay, why do I need to obtain this angle? Because I notice that this is the angle at the center and this is angle x, both angles facing this portion of the arc. So this is the angle I am going to use to get angle x. Still applying theorem 2. Of course, getting this angle is not an issue. All I need to do is just subtract this from 360 because this is the sum of angle at a point. So to obtain that angle, it becomes 360 degrees minus 114, which gives me 246 degrees. Upon application of theorem 2, since I've been able to obtain this angle, I can apply theorem 2. Angle at the center is twice the angle on this point of the circumference. Okay, so 246 is going to be 2x. Dividing both sides by 2, x becomes 123 degrees. Okay, so I've been able to obtain x and y applying theorem 2.